Hello, welcome to everyone. Let's see a problem related to inverse function. Let's discuss the topic initially. This questions were taken from IGCSE textbook, but it is common for all sorts of examinations and all boards of syllabuses. Let's go into this. Recall the definition at first, and then we move on to the problem. Okay? Yes. Come on. Inverse function. A function, if a function is both one and one and onto function, we know that what we mean by one, I guess. One and onto. Shall we draw once? One. Suppose we let's just draw. Here you think two elements are there. One means what? Like that. It is easy to grasp. Suppose we can keep the hand on this side. We can close this side and see the arrow. Here the one element is defined with two elements. Sorry, two elements from the domain is defined to a single element. So this is not one. Suppose 1 minute. Suppose we have the lines as like this. Each line is mapped with two different lines. Like the way this is one. Suppose the range is only, the codomain is only 2, means there is no extra element in the range. That is codomain. A codomain is equal to the range. If this is a chance, it's known to be a onto function. Okay. Just we for the function we have to see the domain. If suppose all the elements having a single mapping means this is a function. Suppose if we have like this means say same element is defined to two different elements means this is not a function. We know that. Suppose when we close the domain and see only the codomain and the lines, suppose these lines are mapped to a single element or two or three lines are mapped to single element means this is not a one. Suppose each lines are mapped with only one element means this is one. Suppose the number of elements in the second that's a codomain page is equal to the range, that is equal to the mapping mapped elements means this is onto function. Some of the functions have the peculiar property of both one and onto. Such functions are said to be the bijective function. For the bijective function we know that the inverse exists. Okay. So there has a one simple logic. Initially, we have to check the bijective map. If it's a bijective, then inverse does exist. That important part of the important equation is that f inverse it's using the composite function that we discussed in the previous video. Okay. Okay, then we can move on to the how can we find the inverse function of the function. Suppose our one function is given like 2x, f of x equal to 2x means how can we find the inverse function? That would be a simple question. Let's see. Step 1, replace x by y and vice versa. Suppose y equal to 2x. Now let's take the variable that the function is y equal to 2x. Okay. Now, first, as per the first step, x equal to 2y. Replace the variable. And step 2 means rearrange the equation subject to y. We have to get y equals like the way. So, x by 2. So, we can keep this as g of x. This g of x is a function of, inverse function of f of x. Suppose we need to verify means, we just verify this equation. Okay. Uh, let's move on to the problem. The question is that for each pair of function f and g, we have to verify whether these are inverses to each other or not. Okay, shall we check? Yeah. The first function is given as f of x equal to x minus 6 and g of x equal to x by 2 plus 3. Now let's recall about the definition. F of g of x equal to g of f of x equal to x. If the condition satisfy means g is inverse of f. Okay. Okay. Now let's start with the problem to check. F of g of x. F of first we have to write the g of x, and f is 2x minus 6. Here x is x by 2 plus 3. Then 2x by 2 means x, and 2 3s are 6 minus 6 equal to x. One condition is satisfied. Let's go to the second condition. G of f of x equal to g f of x is 2x minus 6. We have x is a numerator and divided by 2 plus 3. Here x is 2x minus 6. So 2x minus 6 over 2 plus 3. Then after cancelling the 2 on 2x and denominator 2, we get x. And cancelling 2 from minus 6 and over 2, we get 3 plus 3 equal to simple x. Okay. So both the conditions are satisfied. So the result is g of x is the inverse of f of x. Okay. Then we move on to the second problem. The function f of g of x. Can we find this composition function now? F cube root of x plus 2, then x cube minus 2. Here instead of x we have cube root of x plus 2. Cube root and the cube is cancelled. So x plus 2, negative 2, negative 2, positive 2 cancel. So x. Then now we can find g of f of x. G f of x is x cube minus 2. Then g of x cube is a cube root of x. Here x is x cube minus 2 and plus 2 is in the function. Then plus 2 and my negative 2 is cancelled. Cube root of x cube. Cube root and cube are cancelled. So, simply x. Simply x. So both the conditions satisfied. So this is also f for g of x is a inverse of f of x and vice versa. Okay. Then going to the next problem. They are given as g of x equal to x by 3 minus 44. Then we have to find the g inverse of x. We know the step 1. Step 1 is what? We have to replace. First we have to take y as x by 3 and 44 minus 44. Now replace is the first step. Then step 2, we have to change the subject of the formula into y. So that is x plus 4, 44, y by 3. Then 3 of x plus 44 equal to y. Okay. Now step 3, we have to write y is equal to g inverse of f of x equal to 3 of x plus 44. This is the inverse. Are you wish to check the conditions? Yes, we can check. So g of g inverse of x, g of 3 times x plus 44. Am I right? Yeah. Then g is x by 3. So here x is 3 times x plus 44. Then over 3 minus 44. 3 and 3 get cancel each other. X plus 44 minus 44. So x would be the value. Similarly, we can check other side. G inverse of g of x. G of x is x by 3, 40 minus 44. Then g inverse is considered as 3 times, instead of x, x by 3 minus 44. Here also plus 44 in the answer. Then 44 and minus 44 get cancelled. 3 of x by 3 equal to x. So both the conditions are satisfied. So our answer is correct. What would be our answer? It is 3 times x. 3 times x plus 44. That would be our answer. This would be our answer for our question. Okay. So in this session we have learned about what would be the inverse function and how can we find the inverse function using the composite function method. Okay. Okay. Thank you.